Every time I go on TikTok or Instagram, I see one of those turbo air blowers. They become very popular, cleaning cars, removing water, sand or snow, dust and so on. At first I couldn't find one to buy, but now you have them on AliExpress. But I think they are a bit too expensive, so I thought to myself, I bet that I could make one for way less. It has to be small but powerful, so I started making tests with drone brushless motors and small ESCs. But then I found that now you could buy only the motor for something around $6. A few more dollars for the batteries, a 3D printed case, and that's it. So instead of paying $50 for a new one, I want to make my own design. Stay till the end if you want to see its true power. I will share with you the part list and the 3D design so you could make your own. And that being said, let's get started. Check this out guys, even inside of this motor we have a tiny PCB. Nowadays PCBs are everywhere, that's why I want to talk about the sponsor of this video, PCBWay, because if you have some kind of prototype or you are working on a project, if you want to make professional PCBs, you should definitely check their services for PCB prototyping, but also for CNC milling of metal parts, of mold injected parts of plastic or 3D printed parts, and much more. I work a lot with printed circuits and I think I've made more than 100 PCBs, and each time that I use their services, I get very good results. The tracks are perfect, the VS are perfect, everything is working nice, and the price are so low that even if you make some kind of mistake, you can reorder the PCB once again, getting better and better till you have a final product. So have in mind, the next time that you have a project with a PCB and you have some Gerber files, check the PCBWay for their services. And now let's continue with this video. What's up my friends, welcome back. The key for this project was finding the brushless motor, and more important, a propeller. Because you see, a normal drone motor with a drone propeller like this one with 3 or 4 blades would vibrate too much and won't push that much air as this propeller and for the same size. And this propeller is called a turbo propeller. It is basically a full circle of propellers inside of a cylinder. And that creates a way bigger suction and it moves a lot of air while being so small. The entire motor is only 28mm in diameter and 28mm long, but look how much power it has. But wait, the best part of this motor, which by the way cost you only $6, is that it already has an ESC. So you get the motor, the water seal protection, the wires, and an included powerful ESC for just $6. That's amazing. You can see how the ESC can fit on the tip of my finger. I mean, it's not smaller than my design of the brushless sensorless ESC, but even so, it is very small and also powerful, of around 100 watts. By the way guys, speaking about PCB designs, PCBWay is organizing the 7th project design contest. So here you have all the rules. As you can see, you can now enter and participate and win all the prizes. This is an overview talking about the project and the contest. The prizes, obviously you can get the first prize, 1,500 cash, also a coupon and also a robot, and these are the next prizes. As you can see, we have some very cool stuff, and you can get to the submission where you can already see other people who already submitted their projects. The judges, these are the judges, some of these I already know, and also about the evaluation criteria, what you have to do in order to get more points and maybe win the contest. So check the link below if you want to enter this contest. It's very cool. And also see maybe the video from the last year. This is the 6th project design contest. You can watch it and see more or less what people did last year. It should be very cool. So let's continue with the project. I can see that it has a driver and 3 MOSFETs. The driver has the code erased, so I can know for sure what controller this is. And on the other side we only have resistors and capacitors. The motor type is in runner and triple phase. The small PCB here has its 6 outputs connected in delta configuration, so it's small, compact and powerful. This one works at 12 volts, so we could supply it with 3 lithium-ion batteries in series. But this other one here was working at only 8 volts, so we would need only 2 batteries. I didn't knew that, so look what happened to the driver. It got the magic smoke. But wait, there is more. This one here is of 220 volts, high voltage directly from the outlet. And this motor is used for those Dyson hair dryers that cost like 500 bucks. But I bought this motor together with this high voltage driver for around $16. But as you can see, this driver works with up to 400 volts and has a rectifier, and this is a bit more complex. But look, I connect the driver to 220 volts from the outlet and check the power on this one. You can see it on camera, but it pushes my hand back. It's crazy how much power this small motor can deliver. It is rated for 110 watts and is just 3 centimeters diameter. Anyway, I also have a plan on using this high voltage one and make it portable as well with these high voltage generators, but that requires more testing. Today, let's use the 12 volts one. I will use it with 3 of these batteries with a total of around 12 volts. We also need a BMS to charge the batteries. We can find all sorts of 3S BMSs, but I will use this one. It is not balanced and it has no output current limit, but anyway. We need wires and a button. I want to use this rubber button because it's nicer. The ESC has a potentiometer input, so connecting that to a push button, it will put it at 100% power at once. And the next part is the design of the case, and this took me some time to make it small, compact, and also to look good. I've tried to copy more or less the online design, but instead of 2 batteries, I will make mine a bit bigger, for 3 batteries and more power. I make the space for the motor. Then the space where the batteries will go. I added the push button here. And below everything I will add the small BMS with a connector for charging. You could use a balanced BMS and add your own USB connector, or you could also find on AliExpress a BMS that already has a USB connector if you want. But in my case I'll use this one. At the air output I placed a hole for a magnet. And then I've made the tip funnel, which will also have a magnet, so we can merge them together. And the design is ready. But this is like the 4th version, because I had to make a few attempts until I got the right size and shape. Because all the parts have small details for the screws, the button and the charger, I used my resin printer for that. And these are the final parts. I like how the printing bed of my printer gives this nice pattern on the prints. They look so nice. Now we can assemble it. And these should be the connections. The BMS to the batteries to the ESC, and the button from ground to the potentiometer input. And that's it. I first insert the motor into the case. Then we pass the wires through the hole into the battery compartment. I use my spot welder and I make a series of 3 batteries for 12 volts. Connect the red wire to positive and the black to negative. We place the BMS down here. I've connected the push button, but I had to remove it because this one had too much resistance. As you can see, it has more than 50 ohms, which is way too much. So I finally use a normal push button like this one. I add it to the side and connect it to the blue wire. And now we could close the case, but first I give it a short test. It works, but I think that these holes on the back are too small and I can hear how they are restraining the airflow. I'll make them bigger in the design. Also, the battery is not fully charged. So I close the case with these very small screws that are always very useful. I've actually got an entire set of different sizes, and I also recommend it to you because they are very useful for small projects. I add a magnet on the front part, and then I screw it in place. And just like that, the air blower is ready. So let's test it out. Again, I think those holes are very small, so I've changed the design, but I don't want to print them once again, so I will break them just to test it out. Now it sounds a lot better, and as you can see, it blows stronger. But I should also put it to charge and test it with full battery. Okay, so now the final test. I will use this crude setup. It's not the best, but it's good to compare. So let's look at the force that this hairdryer creates in this spot and at this height. It reaches 80 grams, and this is at full power. I do the same with my blower. And look at that, it already reaches 90 grams. Look at that power. But the size and the power between these two is huge, but even so the small one creates the same force. Not the same airflow, but the same force. So guys, you have the links for the motor, the batteries, and everything that I've used for this project below the video. The total cost was less than $15. I am also sharing my 3D design for free if you want to print it. Check electronews.com for more. Thanks again, and see you later guys. Hey guys, so as you all know, making these kind of videos is not that easy for me. It requires a lot of time, a lot of machinery, and also oscilloscopes, power supplies, and so on, and also a lot of modules. And thanks to your support on Patreon, it's a lot easier for me to buy those modules. So thank you very much to all my patrons, and also to you guys for commenting below, for giving likes to my videos, and also sharing my videos to help spread out this information. So thank you very much.